Hello again. Welcome to our tutorial for production oriented Houdini workflows. In the previous lessons, I kind of did the first video I did the breakdown. So now we will be preparing our Houdini scene. So let's launch Houdini. Okay. What I'm going to show is now what we're going to end up with. This two monitor system is not working very well. Okay, I'm not going to show. I'm just going to make it. Okay, actually, let's do it like this. So I'm going to open the file from here. So what we will end up is going to be bunch of nodes, because we are going to also create our cameras, our terrain system, and then we're going to animate our ship, we're going to animate our cameras, and then we need to obviously prepare our outlet work so we can simulate and cache and like do a whole bunch of things in one go. So in the end we will end up with a file, a Houdini structure like this, or we can probably repurpose this along the way. And the way this is going to work is that first and foremost, we will be creating our terrain, which is already cached on my end, but we will all recreate all the structures one at a time, and then we're going to animate our ship, and then we're going to animate our cameras, and then we're going to start creating our simulations, and then we're going to after we create our simulations, we will end up preparing our render layers, render objects, without in a way that obviously we won't be using a farm here, but if you're in a studio, you're going to utilize all the Houdini tricks to keep the IFD files as small as possible. So the IFD file, for those who don't know, is the definition files that only requires a mantra executable to render, in which in most studios this is the only the software that will be running to render your scene. And there are a lot of tricks that involves creating these files that needs to be taken into consideration, like keeping the cache files, because so basically you don't need a Houdini itself to render a Houdini scene. You actually need on the mantra to render a Houdini scene. In order this to work, Houdini itself needs to write out an IFD file that would basically put every single bit information inside this IFD file. So it will make a copy of the BGOs, it will make a copy of the volumes and the geometry and the cameras and everything. But there are workarounds to avoid this. So stuff like that I will show. We're going to be using a lot of disk-based instancing. That's going to save a lot of disk space and memory as well. And then what what I suggest for you guys to follow up with me is that ideally it would come handy if you end up installing Deadline Render Manager, which is the reason I'm using this is because up to 2 users this is free, and the way I am using this is because by using Deadline you can chain link tasks in Houdini or any other software, like running one object and then following it up with Deadline, running some other stuff and then following it up with Deadline. So then you would end up having tasks like it's just easier to follow, and then it will also give you nice diagnostics, like how is your RAM usage, how is your memory usage. You can do simulations. So you don't have to basically do a simulation and in the morning to figure out that there was another extra 4 or 5 hours I could have rendered. So the deadline will take care of that. You can do exact same thing without the deadline in Houdini as well by just not using these deadline nodes. But it's just a lot easier to follow through deadline. And then, which also you're able to, if you set it up properly, you're able to follow your progress through the internet via a deadline server. So it's really handy, and it's free up to 2 computers anyway. So if you have an Indie license, that also means that you can, if you have another computer or 2 or 3, you can just install the Indie licenses in there, and then deadline will take advantage of that, so you can render on more than 1 computer. Okay, so without further ado, let's now start. Actually, I'm just going to show you where that is. So you just, if you want to use it, go to deadline.thinkboxsoftware.com and just follow the steps basically. It is quite tricky to install this on Linux, but it's very straightforward to make this work on Windows. I will not give that support through this. All the information is available if you're using Linux on their website. And then what happens is, in the out context, you end up having deadline submission tool basically. Okay, so this is the outline. This is the my layout that I'd like to use. I think it's quite handy for a single monitor setup. You may want to go. It really doesn't matter what layout you want to use, basically. And I am also using Ubuntu 17.10. I find Linux to be much more friendly when working with Houdini and other professional DCC application, except Max, I guess. Okay, so we are going to now start by setting up our project folder. So you go File, New Project, and we want this to be in this will be depending on your folder structure. You can just put anywhere, and then I'm gonna go here. So this is where I want my project path to be, which is gonna be actually, let's do the projects, right? Yeah, so I'm just gonna get that here. Oops, the T. Ah. Okay, that's it. Okay, no, come on. Select the file. I don't want to select the file. I want to make a new project. Okay, wait a second. Let's give the name. Production oriented. And this is not my path. My path is this. Production oriented project files. No, I want like that. Like that. Take that as well. Project files, production oriented. There you go. Okay, accept. So now we should have the proper folder created. Oh, where is it? Okay, here. Project files, production oriented. I've got everything empty, and then once we're done with it, it's gonna look like something like this. Lots of files inside and a lot more. Okay, so we have our file structure ready, and now we can start by our very first task, which is our terrain. Okay, so I'm going to create a geometry node now, which is empty. Oh, sorry, I'm in the wrong context. Okay, geometry, and let's call this, one second, let's call this terrain hills. Okay, I'm as you can imagine, it's quite a big tutorial, so I'm following this from my other monitor, basically recreating every single step. So I'm just gonna stick to the exact same names, even though if they don't make so much sense. Okay, so now we're gonna start with a height field, which originally I started from the shelf tools, but because I don't really remember, I'm just going to create all the nodes one step at a time. We're gonna start with a height field. Come back. Okay, and I'm gonna punch in the good numbers. Okay, so by size, my grid spacing is going to be 0.175, and my size is 300 meters by 695 meters, 86 centimeters, and I'm gonna give it an offset of 45 meters. And yep, okay, so this is our scene now. It's almost 700 in length and 300 meters in width. Okay, so we're gonna add a little bit of roughness to this. That's height field noise. Height field noise, here it is. Okay, and I'll try to cap the videos in 1 hour unless I close a topic beforehand, because I'll just try to avoid having such big files. Okay, so let's see on our height field noise. We'll name it hills, and we're gonna have an amplitude of 93, an element size of 1 kilometer. Just gonna give it an offset. I just wanted a proper shape for my the scenario that I was just moving the things around. Okay, let's change the noise type to simplex input Perlin, hybrid terrain 7.12. These numbers are just completely random, basically. Okay, we're gonna add another height field noise. Copy and paste this guy. Did we have the grids? This is all correct, right? It's the same. Okay, no problem. All right, now in the second height field noise, we're gonna name it roughness. Roughness, and this one is using so it's using where is it, height as noise layer name. The method is default. My amplitude is 96 here, and because we copied this last one, so the settings carried over, but we need to make our new ones now. Element size 200. Okay, and scale 111, offset 0, improved Perlin again 8, 1.841 for this option, and roughness is 0.5. Now, okay, so we have something. Alright, that looks similar to what I have in the video, so of course I'll try to match all the parameters, otherwise we might end up ships falling off the edges or whatever. Okay, so now we're gonna branch from here. We're gonna have a height field paint node. Okay, I'm just gonna actually activate. I'm just gonna bake this in my other machine, other screen, so I can see what I painted, because I have a hand painted area here, which I'm gonna copy over, but I'm gonna show you first because I want to match the exact outlook in the end, outcome at the end. So basically you can literally, because it's a hand painted section and we don't want to deviate from that, at least for this tutorial's sake, you can always copy it from my file scene that I will provide, just to get the exact same painted out. Okay, so let's go height field paint. Oh, I love the logic search for the, it makes everything so easy. Okay, so then you'll just click here, and then this is set to mask, replace 1, 0, 1, 31. These are all default settings. And then if you select your node, move the pen on the viewport, hit enter, you'll get a paint gizmo. And I will be explaining some of these tools, how it works, because I also want to explain throughout this tutorial how to put keys, how to be comfortable in the UI, and not just show how to do effects, but I guess how to end up being comfortable, or how I at least use. I just like to share that. So now this is just basically, it was originally painted like that, but what I'm gonna do now is just gonna copy this node from the other one, because otherwise it's gonna be very slow. Okay, where are you? Oh. Okay, so because that's what it should look like. Yeah, okay. Let me put the other screen on manual. Okay. All right. So what's next is that I want to blur this. So this was hand painted. So we want to blur this out. There's a node called hide field blur. Hide blur. Okay. And the input goes like this. Okay, sorry, that's my monitor going ballistic. Yeah, I have a problem with my monitor going this siren sound. It's a bug, I think, in the drivers or something in Linux. Doesn't do it on Windows. Okay. Before we continue, I remembered that I needed to mention something which we haven't used yet. But so there are two things that I would like you to do in your Houdini environment file that will come handy. It's about the variables, and so on Windows this will be under your documents folder as well. On Houdini it will be in your home folder. Just go into Houdini 16 or 16.5. This tutorial will work in both, and then edit your Houdini environment file. It's just that it just makes our lives a bit easier. As you can see, I have a few these ones are actually important. So please do copy these in your environment. This is just going to can I zoom in this? No. Okay. So basically, anywhere in Houdini we put a $sign, it's just gonna replace everything with this. Anywhere we put a dollar lib, it's gonna work out like this. So the reason so these are obviously my folders. Like if I anywhere I need to write a $cache, it's actually gonna go here. And because I keep my caches separated for all different kind of simulations, I try not to keep them, but I mean this is the way I prefer to work. You may choose to work in a different way. For this tutorial's sake, we're gonna keep everything in $hip, but this might come handy. I do like to use like this, and the reason I use this is because sometimes I work on Windows, sometimes I work on Linux, and this way I don't have to update any of the texture paths or the BGO paths, and it just works out of the box, and it's just easier. Okay, so let's launch Houdini again from where we stayed. Actually, it turns out that the recording goes on, so we haven't lost anything. I'm just gonna load this. I saved it on a different place. Okay, so where were we? Okay, so we put a height variable blur. Okay, height field blur, and I set the radius to 23. This is just gonna smooth out our we need to. Okay, so so what happened is that because I did not use the mask layer, it blurred out the entire thing, but that's not what I want. So we would like to blur the mask layer, so we're just going to rename this to mask, and so the blur layer is only working on the mask layer now, and our radius is going to be set to 23. Okay, and the next thing we're going to do is that I want to remap the height of this height field using the mask. So I'm gonna put a new node. It's called height field remap. Height field remap. Okay, so my initial shape is my left input, and from my right the mask is going to come. I'm not very familiar with the terrain system, so if there is a smart way, please do update me through emails. However, this is just going to obviously work. If you do the compute range, this is going to automatically get you the mix and minimum and maximum values. But because I've been playing with this previously, I'll just enter the numbers instead. And because because that's where the base is, so we want this area to be fairly flat. Okay, and these are the numbers, -1.833. Okay, and now we're gonna reshape this a little bit to something like this. I'm gonna change the handles to be splines, so it's a bit curvy. Okay, so our next number is somewhere on here. No, I forgot. Okay, you see what's happening here now? So that's what we want to do. And what is the number? Let's put the exact same number. I have two handles. One of them is here. So this guy is at the value. Position is at 0. The value is 28,571,5,714. Okay, and this other guy is at, let's select it. Okay, this other guy is at position. So this guy, right? Yeah, this guy is at position 35109, and the value is 1. Okay. All right. Then we double check that this is still looking the same from the other. Now it looks a bit different. I guess we're just gonna have our own simulation with this version. I don't want to waste too much time trying to see why it's not exactly the same. Yeah, no, that's fine. It's a bit different, no biggie. All right, the next node, and then I have a height field blur again. Height field blur again. Okay. I don't remember exactly why I made these options, but obviously I'll just try to carve the map. I was just probably just throwing in. No, it's, oh, okay. So I'm just trying to flatten it out. Okay, and this goes in here now. Yeah, it's quite the same. Okay, and then turns out I added another noise. So I'm just gonna copy this guy. Oops, no, not you. You. And before my monitor goes crazy, again, I'm gonna save our scene into the proper place, which was project files. This is for me, production oriented. Okay, so let's call it 01 terrain 1. Okay, so 01 will be always terrain, and then from there forward I'm going to increment the number. Okay. Alright, so our roughness values are, this time we're working on the height, but I want to add some roughness in this area, so I'm gonna bring in the mask from here. So the mask got enabled. The values I entered are 4.63, 32, 111181. So it's simplex improved Perlin hybrid terrain, max octaves 8, 1.841, 0.5. That's still correct. So just added some noise in that area using the mask, right? Just get rid of that. Where is it? Original. Okay. So now the other thing we're gonna do now is that we want to add a bit more noise called dirt. Okay, so let's copy paste that, and we don't want any map, so it's just adding it everywhere. Let's call it dirt. I don't know why I call it dirt. And the values for this is now going to be oh, okay, so this was actually a mask, so we are creating a mask layer. So change the noise layer to mask, and then it's gonna start giving, instead of affecting it, this is what it's gonna see, right? And then it's gonna be add amplitude at 2, element size of 500, really big, and sparse comes. Okay, so let's just leave it as it is, which gives I find it a little bit strange, but okay, let me double check. Yeah, that's what it is. It's a mask. We're adding it on. Oh, okay, remove that guy as well. Okay, element size 500. Scale is default 1 by 1 by 1. Change the noise type to sparse convolution. Okay, that looks more similar to the other monitor. Okay, and under this, I think I used the terrain tools while I was doing this, so I guess that's why we're just kind of regenerating one of the shelf tools at the moment, going step by step. So the next thing, yeah, and then I kind of played it a lot. So we want to isolate a layer. So that's another note. And I want to leave it as default. And then I want to create another noise. And call this one. So I want to use the mask and the G itself. And then I want to call this node rocks. And the values for these are, remove the center noise, 0.288, 14.6. It's an alligator noise, and the values are 8, 0.602, 0.602, roughness is 0.6223. Okay, and then I want to layer these guys. This should give a small bumpy surface. Okay, so I want to layer now this with that. So for that, I'm going to use height field layer. Height field layer. So left input, middle input. The settings go add to height, and the default settings, which sees that, which tells me that this may have not been that necessary. It's not too much. Anyway, so now actually this looks a bit different on this other screen. I'm getting this. Interesting. Now I'm just going to double check my settings and how long we've been going for the recording now. 13 minutes, 15 minutes before. That's fine. Let's just save as well. And then, okay, so I think we are. It's looking just a touch different. I'm not sure exactly why, but this shouldn't really be a problem. It's a tiny change, to be honest. Okay, I don't want to burn minutes. I'm just gonna pause the video and go through the settings real quick. Okay, back to recording. Well, I could only find one mismatch, which was the very second node we created. Please turn off center noise, and everything else should be same, and which is kind of, I think, more similar now. Let's get rid of that color. Okay, and all the way down, so we layered our height fields, and we're gonna do some erosion. So there's a node called height field erode, which is pretty cool. This goes into left input, and on the first frame, and the default settings are gonna be amount 1, noise 0.1, debris 5, hydro 1, 0.5, 1, 0, 10. I think these are pretty much the default settings out of the box, which I'm just double checking. Debris as it is, bedrock as it is, layers as it is, bindings, I really don't touch that, simulation. Alright, yeah, so here's the thing. Our simulation frame range is gonna be from 900 to, so the entire simulation, because usually we generally in studios the shots start from 1001, 1000 being the slate, and then it goes from there forward. It just makes certain things easier, and but because we're gonna treat this like one big simulation, so we're not gonna, for each camera, we're not gonna, basically for each camera or each shot, we're not gonna start back from 1001. We're just gonna make it like from 1001 to 1500, and then we're gonna lay out our cameras according to that, and then initially end up with the whole thing. It's just more convenient. So for now, let's just set up the frame range, not 1001 actually, because we're going to have, for now actually maybe we should set it up to 1001. We're gonna change it afterwards. So for now, start with 1001 and then 1300, apply, close, and this will automatically start cooking the erode, so just kill it, because we don't want to simulate that many frames. There's just nothing but flatness. So set the height field erode nodes start frame to 1001, and let's put back to this auto update again. So what this node will do is that it's going to basically just erode our height field based on some erosion algorithms, right? So in my scene, I eroded it only for 10 frames, and then I was happy with the result. So that's what we're gonna do now. So in order for we need to follow after this step, we need to create a time shift node, break the connection, okay, let's say it's 1010, and basically anything under this from this point, Houdini will always show us a height field eroded for 10 frames. So here it's cooking at the moment, and we're just gonna wait for it. Okay, it's quite a high-res scene. While this is cooking, we can also start talking about, I can just show you actually what kind of things we will be eventually seeing here. 1006, let me see. So we'll be doing a lot of wax, obviously, cache cleanup, all the solid solver workflow will be pretty much custom, although I do suggest everyone to start from the shelf tools to see how the connections are made. Once you know where to plug in that specific node, that's when you should basically start building, because because all the shelf tools have been created by side effects, and lots of bugs have been ironed out, just so the user can get a pretty cool outlook. Okay, so this is cooked, and now you can see that we had this all little, as if it rained and stuff flew down from there, which is looking pretty cool, right? Yeah. And what's gonna happen is that because we killed the expression here, from this frame forward, if you do a middle mouse, this is not a time dependent node anymore. If you look here, it's gonna say yes, which means that this node would, if the display flag was turned on this node, for every given frame this would have to calculate, but from this point forward it's not going to calculate anything. We can scrub. Okay, and now we're going to do a few more steps. I just kept going and going on this one apparently. Okay, so after this we're going to create a node called mask by feature. So what this does, mask by feature, this guy is going to give us some slopes and everything else. So we want to, let's say, smooth out the slopes, or we want to create a mask and then create something out of there. So now with this one, smooth radius set to 1, combine with existing, replace, and I want to invert the mask. Okay, so I got the flat areas now, and then I want to leave the values 20 to 70, but I want to change my slope ramp, and that's just because I decided for some reason, in my scene at least. So my first node is this guy, which is the default one. The second one, I moved it towards right to the position 307692. Okay, it just gave a bit more spread, and everything else is off by default. And then I created another one, which I'm going to copy paste this, and I'm going to change its values. And in this one I said 1, replace mask, invert mask, same, but this time I have changed my minimum slope angle to -17.7622, and then I changed my max height to 70.7738, and then I changed my ramp again, that my the last guy, so I don't need this anymore, we can delete it. All the way up, sorry, go up, other one. Okay, we don't need this guy, and the second input has a value of, where is it? Here, position is at 1182.55, and my first point is at 0.10333. Okay, this yes, that looks good. Okay, and then let me cook this. I just want to compare the result. I can't because it's not cooked. Okay, so then my last node is going to be height field mask by object. And by object, now I need to bring in my first, because I want to blur out the area where I put the power plant, right? So it's like where I need to know where, I need to be able to create a mask based on an object. So in order for this to work, I'm going to create an object merge. Okay, and let's save our scene. But we haven't created anything to put in yet, so let's do that now. On the geo level, let's create a node called settlement 01. Let's name it settlement 01. Okay, go inside, now we're going to bring our first asset in our scene. And for this to work, I'm going to copy this now from one place to the newly generated folder that we just made. Okay, so I'm gonna go in my tutorial projects, simulation all. This will be under Geo already, and it will be named. Go inside. This will be named under the base 1 Geo. So I'm just gonna copy this entire folder to the new folder I'm making, which eventually is the one that you're gonna get anyway at the end of all these instructions. So you can copy yours and then start from scratch to continue the lesson. Okay, so where did I put this? It's under Geo. Okay, so paste. Alright, so now we have the whole thing. Now I'm gonna find that guy. $hip Geo base 1B Geo. Okay, here's my base. This is some things I did some time ago. Okay, so what I want is that I want to position this guy based on how I did it before. So that will be 98 units, 11 units, 59 units. Okay. Obviously, in a studio, you're gonna get all this from assets or layout together with the cameras. That's gonna be much easier, but since we don't have that luxury, we're all doing this ourselves. Why not? It's not a big deal. It gives us bigger control. Okay, so I custom I cast the normals. So now here is I'm going to create a primitive group. So group this guy. And I'm going to name this whole thing simulation group. Here, okay? It's a primitive group. It's no, sorry, it's not the whole group. It's based on a screen selection I made, which is just this area. Okay, you can literally copy paste these numbers as the vertex numbers will not change, and ideally you will do that from the file, obviously. But this is the section. If you want to go a hand selection, that's what you can also do. You can go to the selection tool, make sure you're on 3D connected geometry, and then it's going to select a majority of them, but I did that part. That is easier now, which I already selected because this is the part that we want to simulate. You remember that the exhaust pipe or whatever you want to call it getting destroyed? Yeah, that was this. And so now I'm going to put blast. One of these is going to go into simulations. The other one is going to go direct to render. Okay, so that goes straight to render. So put a null here, call it static to render, or anything you wish. Static. This is also the collision geometry in case you needed it. Okay, and I'm just going to select my node that I used to blast this, copy and paste it. There's a delete non-selected here. This is just going to reverse the selection. Okay. It got a bit dirty there, but we'll clean it up after. And now I'm going to create a null. And then say to simulate. Alright. Oh, it's a really cold day. Minus 25 degrees. Holy moly. Okay, so now we can now go back to our terrain because this is this much at this level. So let's go back to terrain hills. Okay, and now we have this object merge. So we're gonna bring all of it, which was actually, let's do this a bit better. So you can call this now. Here, let's call it row base, and then let's bring this in, change the transform into this object, and then find the settlement guy row base. So we brought this in here. Now we can use mask my object. Second input, first input goes in here. It's gonna do some calculations, whatever, and then we have something here now. Okay, so this doesn't look like it's at the right place. Then that's why I'm assuming we need to have some transforms outside. Yes. Okay. Because it didn't look like it was in a good place, so I obviously had some transforms. So go back up to your object level, choose settlement 1 and punch in these numbers, please. Minus 131, minus 34.7. If you don't want this to calculate every time you do things, you can just switch this little guy here to manual. Hello. I think I found out why this has been looking so different, and it has to do something with what's going on inside some of these noise nodes, because the parameters on the outside are exactly the same, but if we, so this guy with the 1 is the one from 15.5, so we got the heels here, right? These are the values, so we go in turn heels low, heel, so okay, so no, maybe there's the thing, this is the roughness. Okay, this is what I missed. Great, found it. So let's go here, let's double check. I'm just gonna go in here, select heels, roughness 0, which hopefully is gonna be a match now again, but if not, then it's difficult to address this without copy pasting it, and it looks completely different. At this level, this is the very first noise node. Maybe there's a post-processing done. Let's just double check that as well, because it was hidden. Who knows? And yes, there's a fold. Okay, let's match that as well, and everything else should match, hopefully. There's a fold. Yep, that's a match. Okay, lucky us. Alright, fold. Oh wow, this took a while to figure out. And then now I have to go one by one. Roughness. Roughness, that looks right. No, it's not. And that's because that's this guy here, which we're going to replicate in here as well. Distortion, enable that as wrap. And then here, you know what? And this enable only this value. It's a bit different. Okay, no biggie. And what's the value? Quickly again, 0.5 to 1. Okay, we're very close. Thank you for your patience. 0.5 to 1. Alright, so our roughness is, oh no, yes, this looks familiar. Voila. Okay. And let's just go to this. Is there another noise? So basically, until here it should be same. Hide field blur. Real quickly checking. Hide field blur. Yep. Now we have another roughness, which is a default one. Thank you. And okay. Now we're gonna just double check here. Just slightly, everything moved out. This is what's gonna happen here too. There's a slight difference. Very slight, but difference. Why? Because we're missing something somewhere. Nothing here, nothing here. That's this guy, I think. No, nothing here. 2.288, 14.6. 0.288, 14.6. Okay. Well, if that's the only one, I'm just gonna leave it as it is. And then the old one. Okay, we're gonna go down to here. I'm gonna wait for this to cook. While this is cooking, cook fast. Okay, this is 10. here, maybe it was already cooked because here. Okay, so now these guys look very different. Okay, so I need to figure out where we made a mistake again. It's not this guy. Go back to add dirt. Add dirt. Oh, we're missing a node. Hello again. I had another crash, and however, I pinpointed the problem with the mismatch, and now it's all working fine. It's just because we forgot to recook the erosion because the simulation, so we need to reset the simulation after we adjust the upcoming geometry, and so we're just going to recook that, and that's just going to look exactly the same as it should now. And from there forward, we are almost finished completing the terrain part, and then we'll start cutting it and chopping it for the simulation, but we still have our ship to be animated, which will be our next lesson. We will be animating our ship and creating our cameras before we start chopping where the collisions, etc. will be. And just gonna wait for more frames. I think this lesson could have been 20 minutes shorter. Forgive me, as this is the first time I'm pretty much doing this through video recording, and I hope the next lesson will be much more smooth. And 1010, and we should be fine now. Okay, so basically the problem was, which this does look now very correct. I'm gonna remove this. It's just I think just a detail here, because here's the erosion line, here's the erosion line. All right, cool. We're gonna continue now. So we had a mask by feature that we defined, okay, and we have another one that is looking rather flat, but it's probably doing something. Let's just double check its values. Mask by slope, mask by feature, okay, mask by height. All right, so here's the thing, this one we're gonna correct. This is not mask by slope, but this is a mask that is based on height, and that was created to kind of give a shoreline for the water areas. So that's gonna be minus 17.7622, 70.7738. So that's kind of gives us the deeper areas. And then my second node position is 0.118255. I'm sorry, that's not correct. It's not the good one. Okay, so this guy is somewhere rather here, which is with a value of 1 and a position of 118255. Yep, and the very left node is at 0.10333. Okay, kind of gives us just the edge area. Okay, and we're going to use these masks now to manipulate our geometry by layering this, and then so first one we're going to need is again another height field layer, and the geo goes in, the mask goes in. Our third input is the mask as well. So this is the third. Sorry. First input is our base terrain. Second input is our terrain 2 layer. And now this guy is going to expect the mask. Okay, so now it's in there, and we can choose the height fit layer, and we want to use the mask layer here. So it's mask, the parameters mask strand 1, base offset, we're going to offset it by 13.8 units, negative, base scale by 147, and then we're going to create another height fill layer. I'm just going to copy and paste this guy here. So this first input, I'm going to cut all this. So for those who don't know, this is why for cutting it's super handy, and it's super short, and it works much better than just shaking it frantically. So the left input goes into height field mask by feature, and this mask by feature 2 goes into the middle one, and then our right input is going to go to our mask by object. So if we have a look here now, basically we're just kind of doing like a little Photoshop work here, plugging in things in and out, multiplying masks. So that's why now we have this map here, basically, as you can see. And now I'm going to do another one, another layer, and this is going to work as a multiplier. And let's cut this out again. Left input to left input, middle to the second layer, and now our values are, I'm multiplying this mask and I'm gonna change the base offset to default to 1. Okay, so it just made it sharper in a way. And then just the final roughness again, and I'm just gonna double check if there are any hidden options turned on, just so it doesn't make another fuss like before. Okay, noise goes under height field layer 3. Okay, and then we are going to activate distortion as well. I think both of them. Yes, lattice warp set to 0.5, gradient warp set to 0.0646. That doesn't look right almost, but it's because we haven't finished punching in the numbers. Amplitude by 1, element size by 1, and change the noise type to flow, and leave the default values. And now we added lots of tiny rocks in here. Looks a little okay. Change the fractal to standard FBM, and this should give us just a touch of additional detail. It just feels a bit stronger than it should. Amplitude 111. Okay, so now next thing we're gonna do is I'm gonna zoom out. So we have our terrain here, and the next thing I'm gonna do is I'm gonna cache this out, obviously not at this level, but later on. So now we're going to convert this height field, and I want to use height layer to be converted and a polygon, and I need a density of 0.75. 1 is probably a bit too much. That's 0.75. So what does this do is that if you do a mouse over, we can get all the extra information like density, a ratio between output resolution and grid points in the source height field. For example, a value of 0.5 will output the half the resolution. And I want to get the point colors and all that stuff out, and this gave us some water area, basically some mountains, all that stuff. But I don't want to keep any of that because I'm not interested in making a realistic terrain render. And it's a great practice to delete everything you don't need in Houdini. That's just gonna help the memory so much. Okay, so put a null here, this now becomes in terrain. Okay, and now we have our terrain ready, and this concludes our very first, a little problematic video tutorial. And our terrain is ready. Our next step will be going through the scatter tools and scattering a very basic forest, and then a few test renders using some kind of disk-based instancing as well, doing a little bit lightning and mantra setup for this to work. So we're going to touch base instancing as well, and then we'll prepare our terrain for simulation. And so I'm just going to save this scene now. Okay, I think that's it. Alright, thank you very much for coming. We will continue with our next lesson in our next video.